You know, when we talk about the Great Pyramid of Giza, we're not just looking at some ancient tomb. We're looking at a literal mathematical and engineering impossibility. I mean, for decades, figuring out how it was built has felt like an entirely unsolvable puzzle. But recently, some incredibly deep engineering analyses have cracked it open, revealing a brilliant picture of what ancient humans were actually capable of. Just thinking about the sheer scale of the 4th dynasty megastructures built for Pharaoh Khufu is absolutely staggering. We're not talking about large buildings here. These are literal, artificial mountains of precisely extracted stone, and they dominate the Egyptian desert today with the exact same authority they did 4.5 millennia ago.
To really wrap our heads around this engineering challenge, we've got to talk numbers. The core structural mass of the Great Pyramid, it's made up of an estimated 2.3 million individual stone blocks. And these aren't just large bricks, they weigh an average of 2.5 tons each. Some of the massive granite roof beams even weigh up to 80 tons. To put that into perspective, that is roughly the weight of an entire space shuttle.
Let's actually visualize that 6 million ton mass for a second. Think about a massive modern structure, like the Houston Astrodome. The Great Pyramid completely dwarfs it. It stands over twice as tall at about 146 meters, and it possesses a density and mass that totally eclipses our modern steel and concrete arenas. It's almost incomparable.
But here is where the math really traps you: the timeline. Historical consensus basically gives the builders about 20 years to finish the whole project. So, if you do the math, to hit that deadline, these builders had to quarry, transport, and perfectly place a multi-ton block every 1 to 2 minutes during daylight hours, continuously, for 2 decades.
That relentless pacing sets up the ultimate mystery of this explainer. How in the world could Bronze Age builders possibly maintain that impossible cadence? I mean, how do you keep an assembly line of multi-ton stones moving at the speed of a modern car factory when you don't have combustion engines, cranes, or even steel?
Well, the very first step to figuring this out is looking at their actual toolkit. Sure, they lacked iron, but they didn't just have basic copper. They relied on superior arsenical copper chisels, which were significantly harder. They used incredibly heavy dolerite balls to just pound away at hard granite, massive wooden levers to pry blocks free, and ultra-thick, multi-ply papyrus ropes to pull them. It really proves that having primitive tools definitely doesn't mean you have incapable hands.
Okay, so how do you actually move these stones overland? If you've ever tried dragging something heavy on a beach, you know that dragging a 2.5-ton block on a wooden sledge over dry sand is a total nightmare. The sand just plows up in front of the runners and creates massive friction. But as modern physics experiments have shown, pouring a very precise amount of water directly ahead of the sledge literally changes everything.
By keeping the water content in the sand at a super narrow 2 to 5%, the builders created what are called microscopic capillary bridges. Think of it exactly like building a sturdy sandcastle. You absolutely need wet sand, not dry sand. Those tiny water droplets act as a binding agent through surface tension. It drastically increases the ground's shear strength, basically turning a loose desert into a rigid sliding track.
This is just a brilliantly simple application of tribology, which is the science of friction and lubrication, and it reduced the required pulling force by a massive 55%. Because of that one trick, instead of needing an entire army to move a single stone, a highly coordinated team of just 41 workers could easily haul a 2.5-ton block right from the quarries to the base of the pyramid.
But getting it to the base is one thing. How do you lift it? When it comes to lifting, all those single-method theories you usually hear about completely fail basic logistics. A straight external ramp reaching the top at a manageable incline would actually require significantly more material than the pyramid itself. And an external spiral ramp? Well, it uses less material, but it completely covers up the crucial corners of the pyramid while they're building it. And those corner sight lines were absolutely essential. Surveyors needed constant visual access to them because the Great Pyramid is aligned to true north with sub-arc minute precision. We're talking an error of less than 0.057 degrees. That is an almost microscopic margin of error to the naked eye. They likely achieved this mind-blowing geodetic perfection by using a solar shadow method on the autumn equinox, constantly checking their sightlines as they built upward.
So the real breakthrough here is realizing they didn't just rely on one giant ramp. It's mathematically implausible anyway. Instead, they used a highly adaptable, phase-dependent hybrid system. They cleverly changed their methods as the pyramid grew higher and their working space shrank.
The most credible structural models lay it out perfectly. First, they built a straight external supply ramp for that bulky bottom third, where about 70% of the entire mass actually sits. Then, for the middle section, they transitioned to a narrow internal spiral ramp, hidden just beneath the outer casing. Finally, as the space became incredibly tight near the apex, they shifted entirely to localized levering systems.
But there's a pretty massive catch. Those 80-ton granite roof beams for the king's chamber? There's no way they could fit those through those narrow internal tunnels. So the engineers ingeniously used the grand gallery as a steep sliding track. They essentially sent a massive 78-ton ballast counterweight cart down the gallery's incline. As it slid down, it mechanically pulled the heavy granite blocks up the external ramp with unbelievable efficiency. Which brings us to the ultimate logistics machine itself. We almost always picture tens of thousands of men dragging stones up massive ramps, but the reality of the workforce distribution is actually shocking. Only about 10% of the 20,000-strong workforce was actually placing blocks. The vast majority of them formed this massive, highly integrated support and supply pipelines.
Honestly, the entire nation was essentially operating as a parallelized assembly line. They built a sprawling 17-acre urban settlement, Hit El Ghurab, purely to house the workers. They had state-sponsored ranches churning out thousands of kilos of grain and meat every week, and they even engineered a deep artificial harbor connected to the Nile just so they could float those massive stone cargo barges directly to the plateau's edge.
Now, even with the stone all the way at the top, to actually hit that insane target of placing one block every 2 minutes, they needed a way to slot them together incredibly fast. Their secret: wet gypsum mortar. Before it hardened, this wet slurry acted as a highly effective temporary sliding lubricant. It meant incredibly small crews could just easily nudge these multi-ton blocks tightly into their exact final positions.
So, bringing it all together, the Great Pyramid wasn't built by a single grand trick. It was built by an entire symphony of perfectly executed methods. The builders successfully layered wet sand transport, external supply lines, internal ramps, massive counterweights, and a literal nationwide supply chain. And the crazy part? They operated all of this flawlessly at the exact same time.
I think the absolute biggest takeaway from this explainer is that solving this mathematical impossibility didn't require any magic. There was no levitation or lost mysterious technology. It simply required the masterful, highly optimized application of basic physics, friction reduction, simple machines, and state-level organization operating relentlessly for 20 straight years.
As we wrap up, I really want to leave you with this thought. Instead of looking to the stars or diving into supernatural theories to explain the Great Pyramid, maybe it's time we fully recognize and just appreciate the astonishing capabilities, the intense labor, and the undeniable genius of our own ancient ancestors. Thanks for joining me on this explainer, and keep exploring.